It does crumble like this, so we start to so we do vacuum it to help keep it clear. But as long as the water is going through it, and you can see the water going through it, so it's not hard to know.
And that's one of the reasons why you want to go through, like talk to the Tennessee Concrete Association or someone who has already put a pervious surface in, to find a reliable contractor who has done work like this before. That's really important.
Yeah.
And Alan probably has a whole, the Tennessee Concrete Association probably has a whole list of contractors who do that kind of thing now.
You can do it wrong.
Yeah.
If you don't get the amount of porous surface that you need, if you don't get the strength, the thickness that you need, actually the one over here is not working as well as it should.
What kind of knowledge do the residents have of these systems? Are they giving you information about
You know, that's a great question. Some, I would say a third really are into it. Maybe 20% are aware of it and appreciate it. 50% probably. It's one of the, I'll answer that question this way, because one of the things that we were disappointed about, frankly, was market acceptance. We
In 2005.
in 2005, yeah. their education was half of our job. Building this, was the easy part, but explaining to people what goes into it and why. We've just spent a little bit of time, and I've tried not to get too far off, but we used to kill our customers. I mean, they would come in and say, look at this, 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 and tell them all the reasons why it mattered. And after a while, put yourself in that place. You just want to flush the toilet and look at the sink and feel the granite and open the cabinet doors and, decide whether you like the tile and that type of thing. And we were trying really hard to impress upon people the value that's really here in terms of the sustainability and the energy savings and the durability and that type of thing. Like I said, 50% of our job, frankly, was just trying to make that case. I am thrilled to see all of you interested in this, because for you, it'll be what you demand. One of the things that we thought was very useful, certification for somebody that's building these buildings is the only way to go. And frankly, as a consumer, it's the only way to go, because it's the certification, whether it's LEED or EarthCraft or some of the other programs, tell you that that building has been inspected by a third party during its construction, has to meet certain measures, and they're actually tested when they're done. You've heard about the blaster door tests and the duct tests. Mm-hmm. Yeah, they actually measure the leakage, they measure the performance, so you know that it performs the same way I'm telling you it does. And one of the things I didn't talk about is the HVAC systems. In addition to the ductless units that we have, there are rooms that have to be ducted. All of our HVAC systems are inside the conditioned space. You can have a less efficient energy system. If it's inside the conditioned space, you're losing very little. Mm-hmm. What happens with most of our HVAC, it's in the attic or it's in the basement, in the crawl space. And your attics are your cold space, because your ceilings are insulated rather than your roofs. And the same thing with the crawl space. Well, you're giving up a significant percentage of whatever efficiency you have. In all of these buildings where we did have to put in ducted units, they're all the ductwork, all the units are inside the conditioned space. That's really important. And then, of course, the ductwork is all sealed up nice and tight. All the registers are sealed and caulked against the sheetrock, where they penetrate the walls. All those things make a big difference. Interesting story about that. When we started these, we had to train our HVAC. We had to train all of ourselves. But our HVAC contractor got into it so much that he started training us. He's the one that introduced us to this more sophisticated systems that I was describing. He said, "Now you got to do this. It works like that. You got to do that." so those, the framers and the electricians and the HVAC systems, they love doing this work. It's one of the first. They're used to being demanded. Get it done yesterday. Go on to your next job. And when we gave them the opportunity to really do quality work that they could see the results from, that's all they wanted to do. So that was a very rewarding thing.
Sorry.
Give
me a show of hands. Who does not know what mastic is? They may not know.
Oh, great.
So tell them,
Thank you.
Tell them about the mastic.
You've all heard of duct tape? No. I don't know what percentage of the buildings, but I'm going to say 99% of the buildings have your ducts. First of all, the flex ducts were not real efficient, but the ducts are put together with duct tape. Well, that's your seal from one section of duct to the next section of duct. that duct tape degrades very quickly, and it loses its stick and it starts to come off, and you're blowing hot and cold air inside your walls and in your attic and in your crawl space and everything.
That
so
you're
you're really
paying
getting
for.
that you're paying for, and your systems are running, much more than they need to. Your houses aren't getting cooled and they aren't getting heated because the air is just going into the building, which causes other problems as well to the loss of the energy. Mastic is a material that maintains that seal. So, and the mastic, frankly, isn't that much more difficult to use, but the HVAC contractors weren't being trained to use it. There's really
It's messy.
the mechanical, pardon?
I think they don't use it because it's messy. It's like the consistency of peanut butter.
It is, it's a paste, yeah, it's a paste. But that's one thing that has changed. I don't know too many HVAC contractors right now that don't use mastic. It's just so obvious to do that. Also, one of the things that to have a certified building, you do what's called a Schedule J. You don't have to remember that, but you actually calculate the loads for the building. You look at the amount of glass, you look at the insulation in the building, you look at its orientation. So what you do is you right-size your equipment for that building. Typically that doesn't happen. You all can build houses and you get your HVAC and they, oh yeah, you need a 3-ton unit, you need a 2.5-ton unit. And the guys come out and they run a duct here and a duct there and a duct there and a duct there and a duct there, and the airflow within those ducts actually doesn't perform like you might think. The turbulence in it has a lot to do with creating resistance to the airflow, and you don't want that resistance. So the design of the ductwork, the size of the equipment, the location of all that ductwork, all matters to the efficiency of the way the air is delivered to the building. So if you're working with the right HVAC contractor, they'll know that and they'll make those calculations. It really is, finding the right subs and having that partnership to build a building as a system is huge. Every building's different. They all perform differently, which is interesting. Yes?
Yeah, but I was curious, how much after the project was all done, how much in percentages was it? Did it cost more as a result of all the green features? And then were there any technologies that just absolutely fell on its face, like just you were really excited about that didn't deliver as you thought it would be? Did you have a lot of subs that just didn't know how to install it, and so that's why it failed?
We did it
cost
over.
More money?
We did it over. Anything that wasn't done properly, we took it out and did it over again. I mean, it did, again, in the beginning, working with the subs that weren't familiar with the framing techniques, et cetera, et cetera, et cetera, it required us being there all of the time. Mm-hmm. Because otherwise, they would do it the way they were used to, which is not bad. They could be skilled, but they weren't familiar with the new techniques. Mm-hmm. And if it didn't get done right, frankly, we did it over again. So, because we didn't, there's really no renewable resources. We don't collect the rainwater. We don't have solar. Those kind of technologies might have given us some trouble at the time. But these are pretty traditional techniques. So to answer your question, other than the fact that we went, like with the HVAC systems, we spent like $24,000 a unit on HVAC systems because we wanted to do that. That's crazy. Mm-hmm. And the 3/4-inch glass, triple pane,
yeah.
That's kind of over the top. It's not crazy, but it made these buildings very special. So our costs were higher than they need to be. We've built enough single-family homes and regular buildings doing all the right things without trying to, really push the envelope. It doesn't cost any more. It just requires care with traditional techniques, and that's where I was going without using renewable resources. Everything in here is done by traditional subs, with traditional tools, with traditional skills, but not the right knowledge. If you have the right knowledge and you take the right amount of time, with the exception of the insulation will probably cost you, if it's $2,000 in that bad insulation, it'll be $4,000 in foam. But as a percentage-wise of the cost of the building and the benefit, it just outweighs the cost. I mean, that's one area that you don't cut out. But other than that, it does not cost more to build an energy-efficient building.
And
on a residential level. A commercial level could be different.
And we're going to go through, we did an economic analysis, as Skip said, on this site, and we're going to go through that after dinner. So you guys are going to get to see, how we measured it, and, the compact, Wendy, for those of you who, you guys have all met Wendy Smith at this point now. So Wendy and I worked with an economist and designed this study, and he interviewed and re-interviewed Skip and all his guys, and Skip said, told us at certain points, well, you need to be asking this, and this is, and we sort of adjusted it as we went along. But now there's this full economic analysis, and you will have access to that entire study because we have it housed on the compact site. But we're going to go through some specific aspects of it after dinner tonight. So
to touch one more thing on the water that I kind of got away from, we did pay attention to the systems. When you were talking, something about what you said triggered that. At the time, the front loaders weren't ubiquitous. They're becoming ubiquitous, but the front loaders were not ubiquitous. So we installed in all of these units front loaders, and I forget what it was, like 1.7 million gallons, some crazy number.
Well, the whole site, the water savings is about 3 million gallons annually, based on what they did.
Yeah.
A million.
And those washers had a lot to do with it. One of the things is the irrigation, and trying to get away from irrigation, but this, at the time, this wasn't a site to eliminate the irrigation, but we did, and they're very simple things. We have low flow heads, so they're very efficient misting heads, rather than the broadcast spray. And we have moisture sensors in the ground, so that it doesn't turn on. It's not a timer. If there's enough moisture in the ground, the system's going to come on. It's like a $500 addition, but for some reason, nobody was doing that. So those two things saved a tremendous amount of water in the irrigation, being really efficient with the layout and the design of the plants and the materials and the types of heads, and having the, you may have there's a difference between a moisture sensor and a rain sensor. The rain sensor just says it's raining fine, but the rain stops and the system comes on. That doesn't do you as much good. So those three things greatly reduce the demand of the irrigation system, and the plants are fine.
And just while we're on this irrigation, let's think about this at the larger kind of level. I mean, one of the things that we're going to present to you for integration into your lives and into your work is the idea that not only was Skip serving himself as a developer, because they were doing cutting edge stuff here, serving all the people that live in these buildings, but in doing this way, with let's take the moisture sensors and what he just told you about irrigation, they were actually serving the community as they were doing that, because there wasn't senseless use of water. So if you think about that, meant then the water department didn't have to spend the energy to get senseless water here. That saves the city money. That comes back on you again as the taxpayer, especially if things like this are done on a community-wide basis. And so there is, when we look at what who sustainability serves, we talk about the triple bottom line, but we also have to, and Leopold will make you think about society and serving societal needs. And I think Dodd, in classes that you'll have with him, will talk about serving societal needs. Joe T.
You talked about at the beginning how you had a hard time getting past some of the coding issues.
Yes.
Have any of those changed? And do you think in the future,
They
what
have.
you've done here maybe have influenced building the future of what's going to be required?
Yeah, absolutely. What we've done and others have done, it has changed. There's a listing now for these techniques where there wasn't one before. It just was on nobody's radar screen, and if they couldn't find it in the code, then you couldn't do it. But now all the municipalities, in part because of the nonprofits helping to educate and make people aware, in part because of the builders that have tried to do this, and the USGBC, these organizations have been making this known and the value of these types of techniques. And yeah, the codes departments have started to pick it up. They're writing it into the codes now.
Yeah, I was just going to say, my husband and I were watching a board meeting where they were trying to approve a house in East Nashville, and they were using a house that had already been approved,
Right.
and they wanted to implement the green stuff, and that convinced the panel to go ahead and let them deviate from what had traditionally been done. So
It's definitely getting easier. And they're starting to incorporate some of the same techniques, just so it's part of the code. They don't have to do it. I wonder, are we like 5 o'clock?
It is.
I just wanted to show one thing. Part of, I don't know what your sensibilities are, but density is a very useful tool. I mean, it really, really is. When you talk about sustainability, that's one of your most powerful tools that you have. And density doesn't have to be uncomfortable or unattractive. And so we wanted this site, it's part of the reason you got different looking buildings and things. So, we wanted this site to be appealing and attractive. And I just wanted to show you, when you talk about having two brick buildings 13 feet apart from her, there's lots of places in other cities where it just becomes like a little pocket park. So we want to walk out through here to show you.
Are the units 1, 2, and 3 bedroom, or what are those?
Yeah, exactly. 1, 2, and 3 bedroom.
You said 40 units per acre.
Yeah. Is it like 40 units?
No, so I'm trying to count, is this like 2 units here, or?
Well, there's 4 units here because of the 4. These are the larger townhouses. There's 8 units in this building. each one of these carriage houses are 2 units. And then there's 6 units over there. And then the final building that we didn't build is another 14. But this